All right, let's take a look at this question. The same thing had happened. I could butterfly this. Myself, I'm thinking this as three different quantities. There's one quantity, a separate quantity, and a third quantity. And if I can get the bottoms to be the same, I can easily cancel out the denominators just like I did in question number 2. And so there's many different ways we can approach this. I personally think of this as quantity A, this is quantity B, and this is quantity C. So this has A, it's missing a B and a C. This has a B, it's missing an A and a C, and this is missing an A and a B. So I'm going to attach to the top and bottom an x minus 1 and x minus 1. Here I'm going to attach a 3x plus 2 and a 3x plus 2. Now you may be wondering, what about the 1? Why don't you take it times 1? Well, multiplying by 1 isn't going to change anything. This is going to get a 3x plus 2. Remember, whatever you multiply by the bottom, you must also multiply it by the top. Now I have the quantity x minus 1 times the quantity 3x plus 2 in both the denominator of the first, the second, and this third term. So I'm able to wipe out the bottoms, and I have negative 4 times x minus 1 plus 6 times 3x plus 2 equals the quantity 3x plus 2 times x minus 1. Okay, we're going to distribute to get negative 4x plus 4, distribute to get 18x plus 12, and now I'm going to FOIL this front, outside, inside, and last. Okay, let's combine like terms here. This combines to give me a 14x plus 16 equals 3x squared minus 1x minus 2. When I move this to the opposite side, it was a positive 14. It moves over, it becomes a negative 14. Was a positive 16. It moves over, it becomes a negative 16. So I have 3x squared minus 15x minus 18. So this trinomial, we can solve this using the quadratic formula, using completing the square, but I think whenever possible, it's easiest to use factoring. And I recognize that 3, 15, and 18, I can factor out a 3. 3 divided by 3 is 1, 15 divided by 3 is 5, and 18 divided by 3 is 6. Now I have a much easier trinomial to factor. What multiplies to equal negative 6 and combines to give you negative 5? It would be negative 6 and positive 1. Negative 6 and positive 1. So I'm going to come off to the side here, and this can be factored into 0 equals 3 times x minus 6 and x plus 1. This is equivalent to this. When I set this quantity, each quantity equal to 0, and I solve, x minus 6 equals 0. I add 6 to the other side. There's one answer. And I come over here, and I subtract 1, and the other answer is negative 1. Now notice, negative 1 and positive 6, if I plug them into the original problem with the denominators, I do not end up with a denominator equaling 0. So these are my two answers here of positive 6 and negative 1.